Session of this day of talks on art and science, and this may be the first in the at least in the recent history of the institute, Isaac Newton Institute, that we have a working composer here. We'll talk about music. Deirdre Gribbin is an Irish composer born in Belfast. She studied music there and in London and in Denmark. She is currently teaching at Trinity College for music near London. She works in all kinds of media, musical media I mean, wrote 2 operas. I just realized she's wrote some music inspired by painting, by dripping water. And this work that she's going to be talking mostly about is inspired by the structure of DNA. Deirdre?
Thank you. It's a great pleasure for me to be here today and to talk to a room of scientists and mathematicians about my work. And also, I come from a world also where the gender balance is working hard to make that up, and we're getting better at that. My background is one actually of a visual arts background. I was going to do art, and then at the very last moment I decided to go and study music and become a composer. I didn't start writing until I was about 21, which is quite late for a composer, but I think it was part of the reflection of the cultural models that we saw at the time. There weren't a lot of women composers to look to. A lot of my work is collaborative. I work a lot across the arts, but recently I've been working a lot with scientists, and I love the idea that the music comes off the platform and becomes something else, and it becomes another genre really. It's not just about music in a concert hall is fine, but that's not the only thing that interests me. And I realized talking this morning and listening to the previous talks, which were incredibly inspiring, that a lot of my work so far has used structure and mathematical ideas. I wrote a violin concerto that was based on the Infinity series, which you can hear very clearly unfolding in the first movement. And I've just finished a piano concerto which went in the post last week, which is based on the Aztec year called the Binding of the Years. So it's a very mathematical basis to the piece. But this morning I'm going to talk about a string quartet that I wrote in conjunction with a wonderful scientist based in Cambridge. Many of you may know Dr. Sarah Teichmann. Sarah and I met when I was visiting Fellow in Creative Arts at Trinity College, and we had 2 years where we talked about how could we write a piece about genetics and music. And it took us about 10 years to get to that point where we actually got to the actual realization of the work. So somebody asked earlier about should artists and the practitioners they work with have a separateness. In my case, it was a very separate thinking about how that would develop, and then in the end it came together very clearly. So I'm going to talk about musical structure, and I'm a really great believer that the living artist should reflect the world in which they live. And for me, the science of DNA provides a strong source of creative energy in my life and continues to do so. Hearing Your Genes Evolve, a new work for string quartet, was premiered at the London International String Quartet Festival in 2013 in the performance space under the hull of the 19th century Cutty Sark clipper at Maritime Greenwich. So there was an amazing little performance space that we created underneath this wonderful object. And this was an era of adventure, of innovation and entrepreneurial world trade and exchange of ideas. The world was moving on, horizons were expanding. And there's a fitting coincidence at play. The Cutty Sark was built in 1869, and that's the same year that the Swiss physician Friedrich Miescher isolated what we now know as nucleic acids, paving the way for the identification of DNA as a carrier of inheritance. Hearing Your Genes Evolve was a result of a year-long collaboration with Sarah Teichmann at the MRC laboratory here in Cambridge. And Sarah and I continuing our work now. She's based at the Sanger Institute, and she's working a lot on specific protein binding. So we're doing work on specific protein applications in relation to genetic anomalies. I believe that science embracing music as a means to convey complex ideas, will encourage public awareness and understanding in a meaningful and personal way for both science practitioner and audience member, as well as for the composer. And that's very much in the spirit of Benjamin Britten, who always thought about the audience and the composer and the performer as having a very strong connection. So what did it mean for me to be a composer in residence at one of the greatest genetic science laboratories in the world? Well, quite frankly, it was a culture shock. I'm used to working with big orchestral sounds where 70 musicians pitch opinions and questions and demand feedback so that they can play my music better. And at the music conservatoire environment, it's very noisy. We've got a lot of music happening all the time. So by contrast, the scientists in Sarah's team work with computer data, with laboratory samples, microscopes in a silently focused and often quite individual way. And it must have been quite a surprise for them to meet me. But after a couple of months, I had a eureka moment when one of the scientists drew a graphic picture using strands of DNA from his work on the 1000 Genome Project, which opened up a whole new thought process for me. And I clearly saw how I could translate this information into music. After a few months, I also noticed that my science colleagues were a lot more open about explaining their work and giving me information in a much more creative way, which I can understand and have a way into to order and begin writing the music. And this imaginative dialogue was now having with the scientists was so refreshing. And I began to really begin to feel and hear the piece. So going back to the premiere, taking part in the pre-concert presentation as color-coded representatives of 2 of the 4 genetic base codes are Maya on the right and Ethan. Maya is Sarah's daughter and Ethan is my son. And there they are to illustrate that although there are more than 3 million differences between your genome and anyone else's, we are, on the other hand, 99.9% the same, DNA-wise. But what does that mean? Well, I'm a composer. I work with variables and uncertainties, with free thinking ideas. It's very fluid what I do. I'm not bound by rules. I don't need to ever justify any conclusions. But I was drawn to this thing, DNA, with a passion for understanding what it is and what it means in our everyday lives, how it functions, and the implications for our long-term health and well-being. The desire to translate scientific data in DNA into a musical language, a common universal language, representing and illustrating the 4 base code amino acids of the DNA, seemed naturally to work with 4 instruments found in the string quartet. Understanding Ethan's differences, he was born in 2006 with an extra set of chromosomes, trisomy 21, commonly known as Down syndrome, was an important catalyst for this specific work with Sarah and myself. A central aim of our work was to demystify the scientific principles behind genetics and make them more meaningful to a wider audience. I used fragments of the DNA patterns from the 1000 Genome Project, and I set about creating a number of musical dialogues between the 4 instruments in the string quartet, which represented variation in how the genetic code transforms and modifies as the components change. But how could we begin to do this? Each person's DNA can be mapped and printed out as a series of numbers, which you probably know, and they are shortened to the 4 base amino acid codes, A, T, C, and G. So this computer printout shows you 9 different people who have a string of DNA, and then genetic variation is highlighted in the colors that you see. So there are lots of areas of overlap to do with repetition, replacement, switching material, and looking at cells and patterns. So what does our DNA tell us, and how does it work? What does it mean? Let's look at the DNA and the evolutionary pot with a few surprising facts. We share 50% of the same DNA as a banana, but in the grand scheme of evolution, we have evolved as humans with the knowledge that we eat the banana and it doesn't eat us. What makes us alive in genetic information encoded in our DNA? There are 3 billion base codes of information that makes us living organisms. The alphabet which encodes DNA is based on the ATC base codes. And I'm just going to show you this little image. Unfortunately, we couldn't get the technology to make it move, but this is a a model, a computer-generated model of interacting DNA, and it does actually move, where you see the yellow move across and form into other patterns. And I'm going to show you another one, which Sarah and I used to also explain our work, where the proteins are actually binding, which is quite nice. So you can see it coming, a little string coming out. There you go. And off it's gone. And that's the switch moment happening in the patterning, and a very nice illustration for that. And that, for me, as a non-science practitioner, is quite inspiring to actually visually see how the DNA is actually happening. So the next thing I'd like you to do, I'd like you to turn to the person next to you, please. And I would like you to look into their eyes. Look at the exact colour. Are they blue, grey, brown, green? So the exact is predetermined by the genetic variation. So we're having lots of conversation about our heritages there. So there is a predetermined prediction. Yeah. It isn't always completely accurate, but normally it is. So there's nothing in this or in the code that resembles anything to do with music. So how could I translate that into music? Well, there are a couple of things for all of you who have any knowledge of music. We have notes in a scale, and the familiar notes that we have in the scales that we're familiar with are the A, C, and G. So I set about taking the patterns and developing note systems around this. Now, T in terms of music could give me the license to be more random, so I created my own scale patterns. And I explored the overlap between the science and the music. DNA patterns repeat and are modified. Letters switch, patterns copy and reorder. Single letters change and are replaced, and this can be represented very easily in the music. So I'm using this as an illustration for myself to look at the head of a sunflower, and of course it's got incredibly beautiful patterns, but I imagined each of the scale systems, because to write a piece of music with 4 notes would be incredibly boring. So to create little cells of notes, and that's another scientific term, of course, but cells of notes in music, which are developing my own little scale systems that would correlate to each of the 4 base codes. So I had little clusters of notes. So if I go into the sunflower head and take a cluster of notes, these are the notes defined for the area that I will use for the A patterning, and the same for the T, C, and G. Okay, so let's look back again at the SNP. And this is called a SNP of genetic code, and it is actually printed out with a lot of number patterns as well. And I'm currently doing a project at UCL on the PGP open access program. We're developing an app which is going live next year, where we are using little fragments of music to actually show genetic differences. So you can click on a person profile, and then you can click on the music. You see the code happening, and then it changes. So that will happen for each of them. And it's very much for the general public to have an understanding through sound. And we were talking earlier in previous talks about the idea of the sensory nature of art as well. And that music is more abstract. Visual art you can look at and you can come back to, and you can have a look at it again. Yes, you can do that with music, but your knowledge of music is predetermining how you hear something and how you arrive at it. And I think it's quite interesting to involve that sense also in explaining the science. So I'm going to talk to you about, this is my piece, Hearing Your Genes Evolve. Now, if you look at the opening, you can see the opening line, AC, AC, CA, was based on a little SNP fragment that I used from the 1000 Genome Project. And now I'm going to play you a little bit from the opening. This piece of music was used in a German film documentary called The Dark Gene, where a German doctor was trying to determine, was there any definite connection between our genetic profiles and depression. And he was also looking at how genetics is played out in a lot of art forms. So these are the Eisenberg Quartet, and they're based in Germany, and this is in rehearsal with them. Okay, so I'm going to move on a little bit because I know that we're pushed for time. So this is a little extract. So that in the first instance you heard the violin playing the A code. Violin 2 plays the G. T had the viola had the T code, and the cello had the C. And then they all switch codes and they go to the C. And I also played around with lots of the musical parameters that are not specific, like the type of timbre, the sound worlds that you get. There's a string sound called sul ponticello, which means on the bridge, which is a slightly glassy sound. So taking the idea of difference and personal difference, putting that into the music itself. And I'll just let you hear that little switching from codes. This is the switch code from one code to another, and you can hear that very clearly in how the music goes from one thing to another. Sorry, keep vanishing from the screen. Sorry. So they're transforming to another code and they're switching to the T code. And you can hear slightly more dissonant pitches coming in. Now they're moving to the sul ponticello sound, very glassy. Beginning to evolve into a new pattern. So we're there into the C pattern. Okay, and this is a section that I'd like to play to you, which is a little bit of a longer section from the film The Dark Gene, and it's me describing to the doctor about composing the music and getting it from the page to the piano and then orchestrating it from the piano into the string quartet. So just give me a moment to find that because it's halfway through this visual example. So that's the opening, and this is how they demonstrated it in the film. Okay, this will be the second clip. Okay, and that's, for some of you, that's the Sanger Institute. So just playing through the different codes that I'd evolved on the piano first.
7 years ago, I had a child who was born with genetic anomaly. He has Down syndrome. So that was the big catalyst for me to suddenly have a renewed personal interest in genetics. We spoke about the possibility of putting together some funding to try and do a residency so that I could understand how DNA can be understood by non-scientists. I spent probably a year working in the lab, and part of this interest for me was, well, let's look back to basics. What is our DNA? What is the genetic information? It's almost like learning a new language. patterns and repetition, and there seems to be a lot of overlaps we talked about, and there is something quite wonderful about writing music which is very open and flamboyant and free, but the parts of music that are very structured are also very important. So it was a perfect source to begin to be able to write.
That's wonderful. I really, really love it.
So I'm now going to describe the
idea of
compositional process.
having the four notes A, C, the G, and the T. I'm made into an E flat, and let's call them cells of notes. So in the same way that you have cells in the science, I talk about often small groups of notes being cells of notes. So around the A, if we look at all of the white note harmony that tends to be around the A, but that in itself isn't really enough for me, so I added within that scale also C sharp, so quite a contrast.
So you've got this lovely minor third or major third, which you can play around with within the pattern.
Took a snip from the centre of a pattern from Thousand Genome Project, and this particular rhythmic pattern really caught my eye. I thought it was something that really stood out, that spoke to me in a certain rhythm. So I translated the note patterns that you have here, basically literally into a pattern that comes.
This is my original sketches that I just worked with pen and pencil at the
C, C, T with the E flat, C, C. And I'll just play that rhythm for you.
Okay, so I'll just stop that there because I realise it now. Okay, so in conclusion, I'd like to just say that I really believe that intuition and imagination, intrigue makes for good collaborations between artists, composers, and non-artists and composers, and open to the whole idea of working beyond the art form. Observing structure and manipulating material and using it to ignite an artistic spark is at the centre of this particular process. It underpins and signposts the narrative from a different subject that is describing DNA in a much wider way, and it's quite inclusive. And I believe that music can help us learn, it can broker an understanding of extraordinary thought process, and it can serve so many purposes for us all. And there is no right or wrong. That's the really great thing about being a composer. You can write what you hear. I believe that science embracing music as a means to convey complex ideas will encourage public awareness and understanding in a meaningful way. This collaboration opened a whole new avenue of inspiration to me to do with the purpose of actually writing music beyond the concert hall. As well as working with my colleagues in Cambridge, I've also been exploring music in healthcare settings with engineers, medical engineers and paediatricians in a hospital in Canada, in Toronto actually, a hospital called Holland Bloorview Children's Rehabilitation Hospital, where we've been developing musical devices with interactive arts and music devices that can actually reduce pain levels for patients who are going in for quite anticipated painful procedures like repeat Botox therapy for kids with cerebral palsy who know what the level of pain they're going to encounter. And we've done studies to show that actually the interaction with the music device takes their mind off it so much that when they come out, the pain levels are actually less. So that's, for me, quite a meaningful, purposeful way to work with music. And I love the idea of taking something outside of its genre and really finding a way of communicating and making it open to a much wider audience. Thank you very much for listening.
Thank you, Deirdre, for this very inspiring lecture. I want to make a comment that in music there is a long tradition of composing on a set of letters, and perhaps the most famous example is the name Bach. He composed himself at least 2 pieces on this motif, and many others that Schumann did and others. Anyway, open for questions. Alex.
So Thank you. It's really interesting, and this version of DNA music is so much better than the DNA music that other scientists have come up with through the
Oh,
years,
thank you.
which was always very literal and quite terrible.
Well, I do say in the film when we're discussing it that you could just put it into a computer and it would come out as a computer writing music. But it's what Shan was talking about this morning, that the kind of, okay, I'll call it baggage or the life experience that you have as a composer. You don't always know why you hear something, in the same way as you don't always know why you paint something. You just have that sense that it's right for that moment. So there was a lot of that in the piece. The structural part of it was probably the most structured piece I've ever written.
In terms of that structure, though, I guess my question was going on to, so the letters of the DNA is really just the very first layer of structure, and then there are very many layers of organisation, the genes, the transcription activators, and upwards. Did you consider any of that structure in your music as well?
Not in this piece, but have been since. Really trying to work out proportions to do with the number changes and the number of times changes happen. Yes, yeah. And I'm really fascinated. Sarah's doing single cell analysis on protein, which is mind-boggling for someone like me who that number, 300 million, is pretty massive. If I were to write a piece of music based on every single variation, we would be here for probably a couple of years. Maybe that's an idea. Maybe I need to think about doing that. But yeah, the beginnings, it was quite difficult to get to that point, to make it a musical piece that had some endurance beyond the life of, this is a science piece about DNA. This is a piece of music. This has been played lots. It gets programmed with Beethoven and Haydn, and it just happens to be about DNA. And there's a very strong connection, as I mentioned, because of my son. When he was born, the medical profession came along and said, your son has Down syndrome, trisomy 21, goodbye. And that was pretty much it. He has a genetic anomaly. For a non-scientist, to hear that, you think, okay, what exactly does that mean? So this is a little bit of why my personal interest is so strongly embedded in this work.
Thank you very much for your very inspiring talk.
Thank you.
When you were composing the music, there's a real strong sense of expression and emotion, and that couldn't just come from the DNA. And I wondered if you had something in mind, or where that was coming from, if you can even articulate the origins of that.
And I think if you were talking to a male composer, they might have a different answer. I talk with my female colleagues a lot about this, that I think women do talk a lot about their emotions in their music. Maybe it's something that somebody needs to look at and study. I very much hear colours of sounds attached to particular emotions, and then that has a trigger effect in terms of structure. So if the emotions are then progressing in a certain structure, if something happens in the structure, that will do something to the emotion as well. The switch elements were a wonderful tool in terms of creating a structure in the music. And you can hear that kind of very earthy cello moment.
It's like a conversation?
It was like a conversation, but the actual DNA pattern for me read as a rhythm. Now that's not musical, it just is how I read it. And every time I read a different pattern, it's different. So I suppose that's just me as the composer making those decisions, but hey, it's my piece of music, so I can do that.
You know about this thing called synesthesia?
Yes, yeah.
Do you think that you consciously exploit synesthesia?
No, I'm not synesthetic, no. I'm not. It's a very interesting concept about how do you hear sound and what do you hear when you hear sound. I find it really difficult to filter sound. So when I'm at the cinema, I'm probably very annoying to go to the cinema with, because I'm constantly analysing the musical rhythm of what's happening in relation to the characters. It's just something I do. And I hear my sound environment in a very acute way all the time. And sometimes you just want to switch off. And then when you're composing, it's almost like switching another switch on, because you're in that world of the music. That I've just finished a piano concerto, and I think that it would be incredible to look at what's happening to a musical brain when you're orchestrating for 70 people, because I literally feel exhausted. I feel like my brain has gone like this. I don't know if it has. Maybe it has. I run a lot, and that's to counteract the physical static nature of being in that brain space of working.
By chance, I've just been reading a biography of the great conductor, composer Wilhelm Furtwängler, and some of what you've said today about how you go about composing resonates with things he said. He was somebody who would know a score by heart to a piece. He would know it in the kind of detail that a computer might know a DNA sequence. But then he wouldn't just say, right, and now I turn this straight into music. He'd then engage with it and think, right, what do I know about the composer at this time? What was he trying to express? What emotions are there? And then this would, we say, Furtwängler would focus on the line, and not just the individual notes or bar by bar, but yeah, sort of a broader structure. And so initially when you said turn DNA sequences into music, I was thinking, oh yeah, sort of, yeah, here's some data and you just work straight up from it. But no, you said, no, there's very much, you are in here, your emotional state, yeah, what genetics means to you personally through your family, it's all coming through there.
I think structures are really important in music because it is something that you have to put into the music. Otherwise it could be a nebulous piece of music that goes on for a long time. And you do have that intuitive side, but the structural side of it is really, really important. And you don't always hear that, or you don't always hear composers talk about it. I think just about every piece of music I've written has some kind of mathematical reference, but I'm not a composer who'll sit down and analyse. And often I'll be doing it so quickly that at the end I'll think, how did I do that? And I somehow think that if I were to be able to analyse, it probably wouldn't be so beyond me, which I think music always is beyond the creator, definitely. And I was struck with what Sian said about artists and relating to the contemporary visual world and science world, and you're right. I do open the newspaper and I see things about genetics and they pop out, or science, or about climate change. I'm very interested in at the moment in terms of the kind of decision making and how as an artist you can not just pay lip service to it but do something quite significant. And a lot more of my work recently is about theatre practice work. I work a lot with, there's a theatre company in London called Chicken Shed Theatre Company, about a third of the membership, who are actually doing Rapunzel tonight. This is the first night, so when you talk about the Rapunzel equation, I thought I'm going to see another Rapunzel later. A third of the membership have some form of learning disability, and to see a performance where that is happening is extraordinary, because it really makes you question how you as a person and what you do in your life relates to the grand scheme of everything. And I do believe, looking at the science of the beautiful icicles, I just saw them as beautiful patterns that have a place in fractal geometry. Now I probably am wrong, but that's how I related it as an artist. And you talked about exciting the second harmonic and the moving hair, and I'm immediately hearing music about the exciting second harmonic that you could have for that ponytail moving. That's just the way I think.
Any other questions? Sian, you wanted to ask?
Well, you almost answered it, really. You said that your pieces are played alongside other things in a concert repertoire. And there is something that is very high quality contemporary music, so you wouldn't have to know where it came from. Are you tuning in also to the zeitgeist of the music world? I mean, it's that relationship between, too big a question, I know, but it seems to me that you couldn't have done this at any other time in history. And your extra knowledge has given you even more depth.
Well, the zeitgeist of the contemporary music world, are you talking about? Or-
Well, I'm not. Yes, in a way.
So-
I mean, it's not Bach, is it?
No,
You know, and,
no.
and it's definitely of now.
It is definitely of now, and you know we're contemporary composers, and we should be reflecting the world we live in, which is not all Philip Glass and Steve Reich, which is lovely, but it's about seeing something that's quite shocking, and you think, okay, well I'm just going to write about that as well, and you're right, but I do think that if Mozart was alive now, he would probably be interested in looking at the contemporary world. All his music would probably be electronic, and he would probably have invented some incredible music apps that we could use, that you could all use in your work, because he was so far ahead of the curve. In the contemporary music world, I don't really feel that I belong to that world either, because of the conveyance of emotion, because there seems to be this great void of talking about emotions in terms of music, and perhaps I just keep going and do my projects.
Okay, let's thank Deirdre one more time.
Thank you.